36 now. Yes, yes, I'm aware. I'm aware. Oh, hey, Jim. Please get seated. All right. Welcome, everybody, and good morning to today's special session organized by the Technical Committee on Planetary Defense and Near-Earth Objects, which I have the privilege of chairing. My name is Alex Karl, and I welcome you all to the Great Planetary Defense Quiz. I'm glad you're all here, and I'll start with pointing out that if you have questions throughout the event, please post them on Slido so that we can post your questions to our distinguished panelists. I'll have the link on each slide, but the QR code is here and just on one more slide. So feel free to take a quick shot now and then get your questions ready. Let me introduce to you our experts today. We are starting with Mariella Graziano. She's the Executive Director of Space Systems and Robotics at GMV Aerospace and Defense. We have Dr. Alyssa Haddaji. She's a lecturer on space law, policy, and ethics at the Harvard University. We also have Patrick Michel. He's the HERA Mission Principal Investigator and works at the Centre National de la Recherche Scientifique. Sorry. And myself, as I said, my name is Alex Karl. I'm an operations engineer and also one of the Planetary Defense Conference co-chairs. Quick show of hands. Who here is familiar with planetary defense? That are not so many. That is great, because you'll get a quick introduction in a nutshell now. So asteroids are rocky bodies. They're leftovers from the formation of the solar system, and they come in all shapes and sizes. And they're mainly located in the main belt, so between Mars and Jupiter, and the Oort cloud, everything further than Neptune and Pluto. Why do they? Some of them, well, all of them, are just like the Earth, on an orbit around the Sun, and their orbit may cross the orbit of other objects, and this is not limited to the Earth. You're probably all familiar with the end of the dinosaurs. That was an asteroid impact. And we can see it on the moon. It's full of craters because the moon doesn't have any erosion, so it keeps track of the history of the solar system, really. And even our Mars rovers found meteorites on Mars. And some of you may remember the 1994 Levi Shoemaker 9 impact on Jupiter of the comet. So we, of course, want to avoid getting hit, and especially getting hit without advance notice. So we are looking for these objects. We do that mainly by optical telescopes, and they're pretty faint. They're pretty small, so they're hard to track. Once they get close to Earth, we can also use radar to find out more about their characteristics and get a better estimate on their size. But the best prevention in this case is finding them before they find us. There are several studies that have estimated the population of the different sizes. We have about 1,000 objects that are bigger than 1 kilometer. And they pose a real threat. They could be, so for comparison, the asteroid that killed the dinosaurs was about 10 kilometers in size. The good news is, those big ones are not very frequent. So nobody needs to lose sleep. We're all safe for the moment. But it's a question of when, not if. The other good news is we detected most of those big ones. We're maybe at 95%, 98%, depending who you ask. We're more concerned about the smaller ones that are more frequent, but can still pose a significant threat to cities or regions even. And the smaller ones might just create an airburst and then create some local damage, like the Chelyabinsk event, for example, in 2013. Some of you may remember the dashcam cameras from the Russian drivers. What I find fascinating about planetary defense is that it is the only natural disaster we can not only predict, but also prevent, given enough time. We can predict hurricanes, maybe an earthquake, but then there's nothing we can do about it. Asteroids, that's a different story. With enough time, we can move them in their orbit and just slow them down or speed them up that they will miss the intersection point in the orbit with Earth. And this is usually tracked by a risk corridor, what you see here. And we have a risk corridor because we don't know the orbit of the asteroid exactly. So this is all based on uncertainty. And we can only move the asteroid across that line. And if you look at the bottom part of the screen, you will see, of course, we can move it, but we have to move it along the line. So we change the location of the potential impact, and hopefully we can move it all the way. You might guess correctly that there are geopolitical issues involved if one country pushes an asteroid, maybe doesn't push it enough, and it falls in a different country. And we'll explore that a little bit. Some technologies that can be used for that are depicted here. We have everything from nuclear devices, laser ablation, gravity tractors, and kinetic impactors. There are some UN-sanctioned organizations who are working on this. We have IWAN, that's the International Asteroid Warning Network. They are tracking all those objects, and if they find one where the probability is high, the size is large or large enough, and it's coming our way with some probability, they will issue a warning to the UN. And if a certain criteria is met, also the same page is being activated. That's the Space Mission Planning Advisory Group, and that consists of mainly space agencies who would then get together and figure out technical options to present to the decision makers what can be done. And with that, it's quiz time. Are you all ready? Let's start with something easy. So we had some technical issues, so there's no electronic participation. So we're going to do this the old-fashioned way, by raising your hands. So let's start with something easy. Who here has seen Don't Look Up? That's a good number. For those of you who haven't, I recommend you check it out.
So all these people are registered to Netflix, by the way.
All right. What is the minimum size of the asteroid above which worldwide consequences are expected if it impacts Earth? So how big would an asteroid need to be to create worldwide consequences? With A, 50 meters. Any show of hands here for 50? Anyone for 140? All right, a few. 1 kilometer. That's the majority. Anybody for 10 kilometers? All right.
The answer is 1. 1 kilometer. 140 meters would be the threshold for regional or small country damages. 1 kilometer for global effects.
So if you like, you can track your correct answers, and then we'll see at the end who has the most. There may be a prize. So all right, next question. How many asteroids larger than 1 kilometer diameter belong to the near-Earth population? So how many are in our neighborhood? A, about 10. Any offers? About 100? A few, okay. About 1,000? Getting more? About 10,000. Okay, so most were at sea.
Fortunately, it's not 10,000, but it's 1,000.
Let's go on. What is the average impact frequency of asteroids of this size? 500 years? 5,000 years? 500,000 years? Or 5 million years?
500,000. $10 million would be for. I was thinking whether we have a slide on that, so maybe I don't.
No, we don't.
So 100 million years would be for 10 kilometers, and 500,000 years to 1 million years for 1 kilometer.
Which fraction of asteroids are expected to have a natural moon in the near-Earth asteroid population? Who thinks 5%? 15? This is like an auction, I like this. 30%. And can I see 60?
So actually, it's not a small fraction, it's 15%, and this is a case of Didymos.
So Didymos, for those, you may have seen the DART plenary on Tuesday. Who was there? All right, so you know all about it, which is great. For those who don't worry, you will hear about it. Then, what do you think is the most important property to know about the object? In terms of, we discovered it's on course to us, what would we need to know most in order to do something? Is it the mass? The size? The composition? Or the rotation rate?
So what you need to know the mass as a first knowledge, and in fact this is what comes into play in the quantification of the momentum that is transferred by an impact. It's really the mass of the asteroid. Of course, in a single question like this, it's not the whole thing, because internal properties are very important to know, because even with the same mass, if it's a monolith or an aggregate, the response will be different. So that would be another thing. But at first order, if you just have one observation, you can have just one parameter, the mass is the most important. One thing that we don't know, however, is the effect of rotation rate, especially for a kinetic impactor. But let's say we have just one measurement possible, the mass is the most important, because this is what comes into play in the amount of deflection you can make.
Thank you, Patrick. Let's change gears a little bit. Let's assume we have a late warning of a potential big asteroid impact. Which technique will you use to attempt a deviation? Who would go for the kinetic impactor? So maybe, I haven't explained it earlier in the slide for background. So kinetic impactor is what DART is doing. It's smacking into the asteroid. Transfer of momentum. Although maybe Mariella, you can explain this better. Okay, yeah, okay, let's do this blind. Let's do this blind and then we'll explain. So, let's stick with, without knowing what those things are, just you get an idea about the name. Who would use a kinetic impactor? It's big? Sorry? What's big? Let's say.
That's true. It's a good question. Yeah, we can elaborate.
Okay. The gravity tractor. Okay, a nuclear device. Or laser ablation.
The answer, in principle, if we really simplify many things, will be C. Okay.
Yeah, the nuclear.
Now, as Dan was assessing, we need to know which is late warning, which is not big. We have to know many things. We shall know the dimension of the guy. We need to know the property of the guy. That's why it's very important that all the different experts in the area of planetary defense, we work together, because the answer is not so straightforward. And at the end, even why we are doing all this is not straightforward, because the idea here is saving the Earth. I mean, it's not going to buy a bottle of water. We want to save the Earth, so it cannot be very easy. Otherwise, I mean, we will be all without a job, no? So, as Alex was saying, there are different techniques. There are different techniques that have been investigating. One is the kinetic. I mean, what we want to do is try to deviate the asteroid. This is the basic. So we want to do something that makes the trajectory far away, that allows the trajectory to be far away from the Earth orbit in order to avoid an impact. Or not only the impact, I mean, it's also dangerous if a massive body comes close to Earth. So the impact is a problem, but also a big body, you know, this is like playing billiard. If a big guy goes to another one and is very big, maybe you can have a problem anyway. So the kinetic impactor is what DART will do on Monday. So it's an impact. So the idea is moving the trajectory. Then we have the gravity tractor, is a kind of other way around. We want to, using the attraction, just pull the body. The nuclear device, I mean, it's a kind of bomb at the end you want to to destroy. And then the laser ablation is really shooting on an asteroid and generating an ablation that will work as a propellant. Now, why Patrick said that is different, because it depends on how the mass of the body, how the structure of the asteroid is. Maybe, Patrick, you want to say something on this? Because it's true that the question is very related to many things. But making very simple before is, if you have sufficient time and your body is not very big, if you send an impactor, you can generate a small deviation that within large time will bring you the asteroid far away. If it's getting closer and closer and it's big and it's massive, and maybe it's rocky, and you don't have time, maybe we will need some volunteers in Armageddon for putting on a nuclear impact and trying to destroy it. Nuclear impact can be dangerous because then you generate pieces and you will lose the control of those pieces. So this is really a technique that shall be used in case of very difficult.
Yeah, I think it's a question of the energy you need to deflect, and therefore if the asteroid is too close to the Earth, you need a much greater energy, and the kinetic impactor has a limit in terms of energy you can carry. Although with the big launchers, I don't know if we could push the energy level closer to what we would do, not as close as a nuclear device. The concept of nuclear device would be to explode the bomb at proximity of the asteroid and ablate the surface by the energies of the neutron it carries. And of course, you carry more energy, so you ablate more and you deflect more. The advantage of the gravity tractor, it's controlled, and that's going to legalization, because this is Newton laws. You have the mass of your spacecraft, you have the asteroid, and you control the deflection effectively because you can adjust the distance of the spacecraft so that you deflect the amount you want. And since it can only work on very small objects because you cannot send a supermassive spacecraft, it only works for objects which do regional damages. So this is where this kind of technique, which is a controlled deflection, has to be checked by my colleague on the right, see when we can use it. So, but in principle, ideally, we want to be able to anticipate and therefore possibly use a kinetic impactor, and in case we miss the first time, because space is always, then we have time to send another one. So for a late, it would be nuclear. Anyway, I mean, if we are too scared, they will send a nuke.
All right. Spoke about it, so this one should be easy.
We did it.
What deflection technique will DART be demonstrating in 4 days? Kinetic Impactor.
Some people say no.
Gravity tractor. A nuclear device. Or laser ablation. All right.
We should say one thing, however. Kinetic impactor, there is no explosive on it. It's just a spacecraft that explodes by itself on the target because the impact speed is so high that it exceeds the sound speed in the material, and therefore you have a shock and an explosion. We do it with a rock, it explodes also. So it's here, when we talk about kinetic impactor, it's just a passive impactor. Just to clarify.
I think that was a good clarification. Thanks, Patrick. Talking about nuclear devices, if one needed to be sent out to space to push away the asteroid, which decision-making body would be needed to make such a decision? NASA? Same page. The United Nations Security Council. I think that's more people than at DART, huh? Or ESA.
The UN Security Council. I'm very happy from all of you right now. Reason why we cannot send a nuclear device in space based on international law. If you look at the Outer Space Treaty, it tells you that you cannot send a nuclear weapon, but even though you don't use it as a weapon, and let's not go into the definition of weapon, if it's a tool that you're using to push away an asteroid, it still creates a nuclear explosion, which is banned by the Limited Test Ban Treaty. The only way to supersede that ruling is for the United Nations Security Council to come up to a vote. There are 15 members. You need 9 out of the 15 votes without any veto power. So this could still be possible. We could still send a nuclear device in space to push away an asteroid, but you would need the vote of the Security Council.
Can I ask a question? We improvise?
Yes.
So suppose it happens. We have a rock coming close to Earth, and then the only way is a nuclear device, and they vote against. Are we all going to die?
Yes. No. They would.
But they will give us wine, don't worry.
Let's read in France. We do these simulations, especially at the Planetary Defense Conference. Every year, every 2 years, you have this scenario, and you have rogue agents, which I like. I was one year just for fun. You know that you're not going to do nothing, so you just, a country, even a private space sector company, and we'll talk about it in a later question, can say, I'm going to send something anyway, and you've seen this in Don't Look Up. There will be legal consequences, obviously. We don't want to say that, breaking all of international law is not a problem. It is. What we want to do is to create waivers ahead of time in these situations. We need to prepare for the possibility of vetoes and what we could do if that happened.
Thank you. Just a heads up for our panelists, we're pretty good in time, so we can elaborate a little bit more. And in the meantime, I would like to encourage everyone also again to go to Slido and submit some questions for our panelists. Moving on, with a double pack here, true or false? Under international law, the president of a country at risk of being impacted by an asteroid must warn its population of the potential impact. Who thinks that's true? Who thinks that's false? A lot of hesitation.
Have faith in your leaders. No, they have to. They have to. Obligation to inform. If it's the country that is impacted and your president or head of government is informed of an impact based on international law, they have to inform their population.
What if, under the same international law, the president of a neighboring country, of a country at risk of being impacted, must provide help to the impacted country and its population? Who thinks that's true? Who thinks that's false?
Yeah, that goes into the discussion of the obligation to act. And there is an obligation to inform and to act if you are the country that is impacted. But if you're a neighboring country, nothing forces you to help. Which is also why we're trying to build those waivers. Because there is a question of liability when you're helping. If Alex talked about it earlier, if you're trying to push something, and maybe I'm ruining a future question, but if you're pushing an asteroid is coming on a country that cannot push it, and ask another country to help. As soon as something is being done for this asteroid to be pushed, and if something goes wrong, even though all the best technology is at play, even though everybody has done their best, the country that has launched this mission to help is liable for damage. So if it were supposed to impact Belgium and it happens and the US help out and a piece of it falls onto China, absolute liability on the United States to reimburse China for all damages, which is what will push countries not to want to help in those situations. So for that not to happen, you need to prepare waivers. So at the beginning of these types of negotiations, countries accept the responsibility and say, I will accept that if something goes wrong, I will cover damage because you're helping me and this other country will not be able to sue you.
The question is, do we have enough time to get those agreements in place before this happens? Because
this is why SemPage has a legal working group. But that was the point. SemPage was founded in 2015. Immediately, a year later, they created the ad hoc legal working group, which I have the pleasure of coordinating. 15 international space lawyers. We're getting back to work this September because we finished our first report, and it was looking at international law and seeing what was there. And now we need to start building those waivers and strategies as to what would happen and create the legal tools to prepare for that. But it takes a lot of debate and negotiations. In the end, this team is a team of academics who know the law, and then it has to go through the chain of decisions, which is why it's so important to talk about this in venues like here or at the Planetary Defense Conference when you talk to heads of agencies, because they're going to be the ones who are going to have to authorize those waivers. We can build them, but they need to be understood and then signed.
And this is very interesting because as a scientist, I work in these groups, and I saw the scientists at the most craziest ideas, but the legalists, they think about things that are actually real, but sort of crazy initially. Can I ask a question?
you may.
So when you say the president of a country at risk of being impacted must warn its population, the question is when? Because initially you have a corridor and many countries are at risk. So suppose it goes through India, big countries, and they all warn the population. So when?
We do these simulations as well. Right now, there is nothing in international law telling you this is when you have to warn. So we actually do citizen science in a way, and we went to schools and universities, and we simulated just to see what the population expected. And you have this sort of always big debates and discussion as to if a country doesn't say, but the other country says. Nowadays, one country, one citizen can just share the news. So when is the country liable and for not having shared the information enough ahead of time? I think in that specific situation, we would turn to SemPage and we would turn to I1 when the information is scientifically confirmed, and then the presidents would have in a specific window to share the information with our population. I think it would have to be from the scientists to confirm the impact.
Just as gossip, you would be surprised from sometimes even in something like this, what population is scared for. In one of the exercises, I remember that they were scared for the lack of internet connection. And I was thinking, there's an asteroid coming, we are going all to die, and our major problem is the lack of internet connection. It's true, I'm not laughing.
I mean, I think there was also a misunderstanding with, we hear about space weather and like solar storms that could disturb the internet. And so I think there was this, an asteroid is coming. The internet is going to be gone. That's problematic. And we had to explain that it would be a little worse.
Very interesting. So any future space lawyers in the room, this might be a topic for you to tackle. Go speak to Elisa after the session. All right, we may have touched on this already a little, but so if the asteroid were to be pushed, but the mission partially failed, and the asteroid fell on another country than the one it would have impacted if nothing had been done, what would happen to the country in charge of the mitigation mission? Was it A, nothing, they did their best. Or the country in charge of the mission would have absolute liability for all damage caused by the asteroid. All right. It would request of the country that was spared to help the country that ended up being hit by the asteroid. Or it would be sued for having missed pushing the asteroid completely off Earth. Looks like the majority.
Very good. The response is B. If it fails, as long as a country has started a mission and changed anything about the trajectory or anything about the asteroid, there would be this absolute liability. Thus, the necessity of waivers.
And that's the waivers you talked about. You're looking for that you have.
You have to sign and agree that you would not sue the country that is helping you.
Great. So, what if that planetary defense mission was sent by a private company, for example SpaceX, who would be liable if something went wrong? Is it NASA? Is it SpaceX? The US government? Or the United Nations?
Well, it would be the US government, because under Article 6 of the Outer Space Treaty, all private companies fall under the ruling of the government that they are registered to. So technically, SpaceX could be sort of sued, not the right term, by the US government. The government could say, you should not have done this. But this would not happen, because when you have to launch a mission, you need to have licenses, and the licenses are provided by the government. In the United States, it would be the FAA, the Federal Aviation Administration. So if there were to be a mission, the FAA and to the US government through the FAA would give the license to SpaceX to send something. And if something went wrong, it would not be on SpaceX, it would be on the United States. And the United States would have to respond to the United Nations. It could go up as the La Hague International Court of Justice. And the government could potentially punish SpaceX for a problem in the mission. But technically, if the license was being done and given, it means that the government agreed upon and green-lighted the mission. So after that, if something goes wrong, the US would not turn against SpaceX, but it would be liable for anything that SpaceX would have had done in terms of international law towards other countries, and that would go to the United Nations.
But would it be the same for all countries, like if a private company in France does something?
Exactly. Any company where the company is registered, it falls under the country where the company is registered.
Do you think in that case the government would approach the company who's most likely to do something to be on the same page, or the company does it really on its own?
I don't see a world where a company could just send something, because they wouldn't be able to launch it. Of course, nowadays you have those private space places where they say that they own their launch pads and they do whatever they want, but you still need licenses to be able to launch anything. So they wouldn't be able to be green-lighted. If they did it anyway, definitely they would have a very strong response from their government, but still the rest of the world would not be able to sue this company. They would turn to the country in question for not having controlled and organized correctly the way their private companies are.
Wouldn't there potentially be also the case, if the mission is successful, that the rest of the world would be like thanking them instead of and asking for pardon?
I mean, again, it's double side of the coin. If a private company does something a little crazy and goes, I'm going this way, the country can still, even if the mission is successful, and even if the rest of the world, support them and celebrate them, the country can still have sanctions because it gives a really, really bad example for the rest of the world to do whatever they want, and for the other companies in their country.
Alex, it seems that you have something in mind, eh?
I'm not announcing
Take ideas, please.
No.
This is not for taking ideas.
I see there are already some questions coming in, so keep them coming. And we're moving on. We have a few more questions in our quiz. So, having to design a spacecraft for deep space missions, what part of the GNC, that's the Guidance, Navigation and Control System, would you consider to be the most challenging, where state-of-the-art technology can maximize mission objectives and return? Is it robust control to reject all perturbations? Is it autonomous navigation? Pointing stability? Or onboard guidance optimization? Pretty mixed.
This is again a tricky question because it depends on many things, but the answer, let's say, simply, maybe I'll do something bad. How many students are here? This is September. It's examination time. Why do you think it's no, it's autonomous navigation. It's autonomous navigation because it depends, in reality, depends on the phases where you are moving and the distance where you are, your kind of mission. But in reality, we are moving, we are in fast dynamics, very, very far away from Earth. There are, where the communication are slow, so we really need the spacecraft to act quickly. And sometimes, depending when you are very close, maybe to take its own decision or modifying. I don't know if you heard this morning the late breaking news of DART. They are going they have up to 6 hours, she said, before changing. So the autonomous navigation is going to be key. But normally mission, they are ground-based up to a certain time, but where you are very close, where you are affected by even if that small dynamic of the body and you are acting very quick, the autonomous navigation is very important. And then it's true that also guidance, it depends on the way, in engineering, there's no like a one-shot answer. But it seems that you're a guidance guy, no?
All right. How about if you have a spacecraft orbiting and or operating around an asteroid, what is the key driver for the control system? Is it propellant consumption? Communications with Earth? Solar arrays flexibility? Or sun orientation for power generation? The majority?
Many people did not answer, eh? No, we are struggling with this problem. My company, we are the responsible of the Air Agency, and we are at the moment struggling with the problem of the solar array flexibility. Because again, we are far away. In case of ERA, we are going to 2.3 astronomical unit. You are very far away. And you cannot have, like, your solar panel shall deploy. So they are very flexible. And they can really modify your system. So it's very, and also the modeling of those flexible mode is not easy. So in what's happening, and I also discussed with other colleagues, the flexibility of the solar array is really a big challenge. Don't for the engineers, future engineers, start from the very beginning to try to evaluate the mode of your solar panel when you design an interplanetary mission.
All right. Thank you, Mariella. And this is our last question. So if you have questions, I remind you, down there's a link. So what are the criteria for same page to get into action? Is it an impact probability larger than 1%, an object size larger than 50 meters, and predicted within 50 years? Anybody for that? No? Okay. Or B, as soon as I1 issues us a warning, which by the way happens when the impact probability is larger than 1% and the size is larger than 10 meters. C, yeah, good number. C, if the impact probability is larger than 10%, the size is larger than 20 meters, and the impact is predicted within 20 years. So few, okay. Or D, only when an impact is 100% confirmed. Nobody, good. The answer is actually A. Same page gets into action when we add these metrics. B is the metrics for when I1 issues a warning, just so that everybody's aware. And C is actually the threshold when terrestrial responses are being staged. So that's when the disaster management community gets together and starts thinking about, okay, what would we do if this sits within our sphere of influence, and what can we do about it? All right.
Can I make a comment?
Of course.
A positive one, because as you can see, it's been like, the two groups at UN were implemented in 2015, but actually we started to work in 2004, Action Team 14 at the UN. So it's been almost 20 years that we started to organize a coordinated response for this, and this is good. We have legal work, etc., because the plan is to get prepared before we need it and not have to improvise. And when I compare to the pandemic, which is the same kind of problem, low probability, high consequences, needing a coordinated action, having all the same protocol, etc., I was very surprised. So the good news is that for planetary defense, we do the job. So that I think is great.
Thanks for the positive comment, Patrick. All right, it's Q&A time. If you haven't, here's your QR code. And down in the bottom, I hope you can read that.
Do we know who had the best answers?
Sorry?
The answers of the quiz. Do we know who had like perfect answers?
Oh, good question, good reminder. Who kept track? Who had everything right?
Okay.
Nobody. Okay, that shows me you're honest, which is good. And if you had everything right, you should have been on the panel as well. So, how do we do this? I didn't count.
How many questions were there?
That's the question.
Can't you put the questions on the screen?
There were 9 or 10?
I think it's if you, hold on, we do it this way. We ask the first question and let the panel answer, and in the meantime I check how many we had, and then we do the scoring this way. So let's start with this question. How does a nuclear device how can a nuclear device be launched? Do we have one ready to launch?
Interesting. So not really, although so there are some people doing numerical simulations of a nuclear device explosion in Los Alamos, Lawrence Livermore National Laboratory, and they think that if we need it, we have a way to do it. So that's the only thing that I can say. And as Alisa was saying, we cannot test that, fortunately, in space. So there will always be a risk the first time we do it. In particular, if you want to explode the bomb at proximity of the asteroid, you need to make sure you explode it at the correct distance. So I'm pretty sure that if we need it, the UN will go rapidly to vote in favor of it, and that some countries, I won't name, will have the capability to launch something. But of course, it's no guarantee. It's not because we say a nuclear device is the best option for a last option. It's not necessarily the option that will work initially.
And I will add a quick thing, something that is a real risk if something goes wrong at the launch pad And so you would have a nuclear explosion on Earth. So that's one of the big legal issues and political issues if we were to greenlight that, whether we have to push an asteroid or something happens and we need to send a nuclear device or weapon in space. The probability of something going wrong on Earth is something that needs to be considered.
And this is why we do all this in order to avoid this scenario, like doing the inventory, which is critical of all the potentially hazardous asteroids. And so we now have the 1 kilometer ones, and we would like to have the inventory of the ones larger than 140 meters, who are about 25,000 in terms of number, and we only know 40% of them. So the good news that the impact frequency remains low. It's like every 10,000 years. So although the risk is not zero, it's super low. So that's why I sleep nice at night. I mean, no, but not because of this reason. But fortunately also, that's why the US, the NASA is pushing that US Congress funds the NEO Surveyor mission, which is a space telescope that will do the job in 10 years. So in principle, when this mission will be launched, and I think it will be just a matter of when exactly, after 10 years, we, in principle, won't have to worry about this problem, because we should be able to anticipate on a longer term a potential impact. So the inventory is critical for that.
Yeah, I agree, and I really see the nuclear one as kind of last chance. So I would really don't worry about certain things, because if it's your last chance, you have to do something. But yeah, it's the importance of the planetary protection, and why people like lawyers, scientists, engineer, communication, medical doctor, whatever, politician, we are all working together and pushing for a planetary defense coordination that shall be worldwide, otherwise it doesn't make any sense, is because if we do things in advance, let's say the risk, I mean, we are talking about big dynamics. The deep space is very big. So if we succeed in getting to know a potential danger quite in advance, and we have observation from ground of that body, and we have technical capability. Here in Europe, we also made a project where we, in order to prepare, for instance, how you can adapt big teleco in a very short time, big teleco platform for hitting, impacting an asteroid, the time that you need, because there are, let's say, massive space, as Patrick was mentioning before and myself, this is a matter of energy. It's really like kicking, and due to the dimension, very small deviation can generate on large scale big trajectory deviations. So it's really important, all the pieces of planetary defense, which is the observation, the preservation, and then at the end, if they don't do their job, then it's our fault. Then the engineer will come, we will make our approximation, so you have by design a problem, and we try to do our best.
All right, so let's come to the results. We have had 16 questions. So nobody had 16, anybody had 15? 15, very nice. After we're done, please come to us. We have a little something for you.
I think we can applaud him.
Oh, yeah. Anybody with 14? There's one. Okay, we have 5 more, so, no, 4 more. So 4 more. 1, 2, sorry, 3 more.
13.
13. There's 1.
2, 3. That's it?
There's 1 more, okay.
There are already 5.
Yeah, now it's 5. We're good.
Now it's 5, perfect. The 5 of you, please come see us after the session. Acknowledge you for your outstanding planetary defense knowledge.
Next year, the prize is next year, the 5 of us will be here answering.
All right, let's go to the next question. We have a question about when using the kinetic impact method, like for the DART mission, without knowing the center of mass, how do you avoid the asteroid purely rotating? So to just spin it.
Okay, yeah, that's a good question. Well, we're not sure. Effectively, this is a question, what will happen for Dimorphos? We may, there is a scenario where we could even put it in a chaotic libration mode. So basically we assume, in the case this time of the secondary of a primary system, that it is spin locked. You know, like the moon around the Earth, we always see the same face. This is a stable configuration for a binary system due to the tidal forces. So it always shows the same face to the other body. But depending on where we hit it, if we don't hit effectively at center of mass, we may put it in a libration. And this libration, depending on how much it is, could go into a chaotic motion. So the effect of not shooting on the center of mass on the rotation is not really well known. So we can just say that. But the smart navigation camera of DART is hopefully smart enough to be able to shoot not necessarily on the center of mass, because you don't know the mass of the system, but the center of geometry, which, if the density is not too inhomogeneously distributed, should also correspond to the center of mass. But we have to assume that. There is always be some unknown, because unless you go first, you have a precursor mission that tells you about the characteristic of the asteroid, you are still blind for some aspects. And that you cannot avoid. That's why if we know in advance that an asteroid is come to us, and if the celestial mechanics allow it, the best is to send a precursor mission that give us all the information we need to make the best design of the kinetic impactor or any other deflection method.
And we have a follow-up question on that. So that will probably not hit the center of gravity of Dimorphos, which results in a change in angular velocity. But as you said, we don't know it yet. How do we calculate DART's impact?
How do we calculate DART impact? You mean we model the DART impact? How do we model it?
I understand the question. How do we measure how the orbit has changed if we spin it?
So DART, it's at 6 kilometers per second, it's about 570 kilogram. And so the small moon rotates around the primary with a period of 11.92 hours. And DART will come in the opposite direction of the moon. And at minimum, we should change the orbital period by 73 seconds. When I say at minimum, it's because if the momentum that is transferred to the target is only the momentum of DART, which is its mass by velocity, then we will change by 73 seconds. However, if some ejecta are produced and they go in the other direction of the impact, by conservation, the momentum they carry adds to the momentum of the projectile. In other words, the more you have ejecta, the more you deflect. And that will reflect in the change of the orbital period. So it could be a reduction of 73 seconds or more. And this will be observed from the ground, because we have an observational campaign worldwide, even in Antarctica from the Côte d'Azur Observatory. We have a telescope there, in La Réunion, and in other places in the world. We have also the James Webb and Hubble Space Telescope, and they will look at the occultations. So when the moon goes in front of the primary, the luminosity of the primary is reduced, and the duration between two reductions tells you the orbital period. So we made the measurement before, we know it's 11.92 hours. We do the measurement after, and the difference is effectively what happened. But that's just the change of the orbital period. As I said earlier, if you really want to know how much momentum has been transferred, you need the mass of Dimorphos, and this is where the Hera mission by the European Space Agency will come into play to measure the mass and have a direct quantification of the momentum that is transferred, which is the information you want to know if you want to extrapolate to other scenarios, like when you want to deflect a single asteroid. So this is how we will measure the outcome, is by measuring the orbital period change of the secondary, before and after.
Let's go. Maybe it was a not so serious question, but it got the most upvotes, so I respect the room. When you were using earlier Belgium as an example of being hit, is there something Belgium needs to know? I work in Belgium.
I wish to apologize to Belgium personally because I always use them as an example. And it's starting to sound shady. No, we're not hiding anything. Belgium is a relatively small country, and so we expect that if a country like Belgium or Luxembourg, or Liechtenstein were to be impacted, they would probably turn to a large space agency asking for help, or a coalition of agencies. So that's why I use Belgium, but no, Belgium is safe. They have chocolates. We want to protect them at all costs.
Anyway, consider, no, maybe I'm even making worse things, but I mean, for instance, Liechtenstein or Luxembourg, they are so small, it's impossible, maybe it's impossible to impact them. It'd be really unlikely that you will impact.
But you know, about small countries, there is a story, like in the 90s, when the first workshops took place about planetary defense, and in the initiation of Gene Shoemaker and Pete Warden, actually. The main worry was they did a workshop in Vulcano in Italy, and they had to do a report about what kind of worries we could have, like this one. And the main worry was, what if a meteor explodes in a region which is super tense in terms of war, etc., and one country could think that there is a nuclear attack of the other one. And at the epoch, we were thinking about, Kashmir between Pakistan and India. They both have the nuclear weapons, and we were thinking, well, if a meteor explodes in this region, one could think the other one is attacking, and that could generate a nuclear war. And that was a serious concern, and they made a report on that just to alert the politician about this scenario, that when there is an explosion, we have first to check whether it's a meteor, and that's why we have all these spacecraft that observe the Earth and allowed us, by the way, when they released their data from some years, that there is the equivalent of one Hiroshima bomb exploding in the atmosphere every year due to a meteor impact in the atmosphere. So it's a little concern. Yeah.
I would like to share also another anecdote about the importance of cultural impact. We did in 2017 the scenario at the Planetary Defense Conference, and it was in Japan. And at the time, nowadays we invite head of agencies, but at the time the scientists were playing themselves, kind of model UN for those who know this. So they were representing their own country. And it was quite interesting because it had to come to a vote where do we use a nuclear device to push away this late discovered asteroid. And the representative of Japan refused, explaining that Japan had a long history with, having been impacted by 2 nuclear bombs and did not want to send it. And when you look at the UN Security Council, Japan does not have a veto power. So we ended up with a situation where in the simulation, the United States and Russia decided for Japan to send a nuclear device, even though the country that was supposed to be impacted refused to use it. So simulation, scientists, it was of no consequence in terms of policy, but it made us think of what kind of discussions we need to start.
And that's a good point you mentioned, Alyssa, that scientists used to play decision makers. We have every 2 years a Planetary Defense Conference. The next one will be early April next year in Vienna. And as you may know, Vienna houses the UN Committee on the Peaceful Uses of Outer Space, and have lots of permanent missions there. And so we're trying to get the representatives and actual decision makers to be involved in the exercises next year, to get a more realistic response, and also to make them more aware of the issues. Okay, next question. Given that the kinetic impactor is passive, one has to be sure it will deviate enough or to create small debris. So I read this as, so as you said, the kinetic impactor, it's not an explosive by itself. So how can we make sure there's enough ejecta for it to have this extra push?
That depends on the structure of the asteroid. That's a problem, that if we don't know the structure, like for instance for DART, we did the modeling of the impact. Same impact energy, we vary the internal structure, and we find that the crater could be 20 meters, but we also find that if the body is super weak, and actually when I say weak, is still stronger than the asteroids Bennu and Ryugu that we visited with Asteroids and Hayabusa 2, then we could entirely reshape Dimorphos. So not even leave a crater. In other words, the crater would be larger than the object. We didn't find a solution where we destroy it, but we may not have covered the whole parameter space. But we improved drastically our models thanks to the knowledge we got from the past missions. Because when we started DART 10 years ago, we were pretty sure we do a crater of 10 to 20 meters, etc. And now we know, no, that's not the case. So it's very difficult to tell you how much ejecta you have when you do a kinetic impactor mission, because we find that there is a wide range of possibilities, even wider than we expected before, as a function of the property. That's why I was saying, so DART is good because it's a blind test. We don't know anything, and we'll see how capable we are to make a deflection on a purely non-educated test. We only know the size of Dimorphos, not even the shape. So I take the opportunity to say, pay attention at midnight next Monday, Tuesday, because for the first time, and thanks to NASA, the public will discover with us a new world. Like, we are as ignorant as all the public. We don't know anything about these objects, about the size, and we scientists are going to discover in live and at the same time as the public what we're dealing with, which I think is absolutely fantastic. And we don't know what's going to happen.
And if I may add something to what Pat is, again, just stressing the importance of working together at international level, because again, we are treating a very, tricky problem, if you allow me. DART is going to test certain technologies, the impactor, also navigation for impacting. There will be an observation of a small CubeSat, but and lots of information will be gained there. And then ERA will become, in some years' time, to really get other information so that the scientists can tune or can verify their model. And it's very important, those kind of, DART and ERA are common, they are going in the same direction. The two missions are key by themselves, but the results of those two missions together is going to be incredible for the entire community. So we really need to make aware to our countries, to our politicians, then when a problem is so complex, when a problem is affecting the entire world, we need to work together and putting together all the information that could be needed for attempting an action. Because we have to be. NASA is doing something great because there is a possibility that does not go in the proper direction, but it's important. It's important, and having the possibility that scientists, mission, and we all, common mortal, we can see this impact is fantastic.
Yeah, I hope so. You tune in. It will be on NASA TV Live. As we said, Monday night, Paris time. It's going to be a good program. We have about 5 minutes left, so let's see. Maybe we can cover one or two further questions. There's one for Alyssa. How many times did we not manage to save the Earth during those simulations?
Okay, so no, at the PDC, there are two different things. I run simulations with my legal students and my science students, and it's interesting to see which one saved the world or not. But for the Planetary Defense Conference, the one time it did not work out was specifically because the scenario was designed for us to fail. Because one of the big things that needs to be coordinated is evacuation, is how do you help the population if the asteroid strikes. So whatever the scientists had to do, and it was a depressing week. They were trying every night because you had the updates, and they were doing their best, but it was designed for the asteroid to impact anyway, and yes, so the mitigation failed, but the point was there for the community to train and to learn how to coordinate about moving the population. And I think it was falling on New York and Manhattan. Yeah, that was...
The funny things was along the exercise, the place, originally it was New York,
yeah,
and it was where most of people were worrying about the lack of internet, but then it was moving because you were doing action, and along the week, this exercise, there is a kind of update every day, and along the day, the treat was moving, also going then outside the US and generating other problems. So I really advise you to go to the Planetary Defense Conference because the exercise is very interesting. And so you can see different aspects. I personally, every time I go, I put myself in a different, I'm an engineer, but the last one I was in the communication. Next one I will be with the firemen, I think, see what happens there. But it's really interesting to see all the different perspectives and how the problem can change and how the difficulty the problem can increase because of, let's say, diversity in legal action or in legal design of the country where the impact is going to happen.
In the other exercises, actually there were three. I have a group with the lawyers, a group with a student studying law, scientists. Usually they save the world, to be honest. And then when you do the simulation with the general public, this is when you have wild cards because they play out as if they imagine how certain country representative would act. So you have the representative of China and the representative of Russia that become usually big caricatures, and it does not help the simulation. But it is kind of interesting to, I think I did it 30 times at this point, and you're always surprised, and you never expect this wildcard of this country being like, veto, and oh, I made this and veto, and it's complicated, and it shows you that you really, really need to prepare ahead of time. But I would say one fun thing, if we can see this as a fun situation, they usually send everything. At the end of the day, after 3 or 4 hours of negotiations, because one of the things that we remind them of is if something large hits one side of the world, the other side is going to be impacted. The economic crash that will happen, the amount of population that will come to their shores, you saw that with COVID. Imagine if a rock destroyed half of a continent. Everybody would be impacted. And that's that piece of knowledge that really changed things and makes everybody just send everything out. And most of the time it works.
All right, thank you. With that, our time is up. I thank you all for participating and increasing your knowledge in planetary defense. I hope you learned something. I hope you're all watching DART on Monday. Go DART. Thank you again to our fantastic panelists, Mariella, Alisa, and Patrick. And if those 5 winners could quickly come up. And for the others, thank you for coming and enjoy the rest of the day.